Hello everyone, this is Dr. K. Mamata, Assistant Professor, Department of Mathematics, Vardhaman College of Engineering. In today's lecture, we are discussing about division by t in Laplace transforms. And the statement of division by t is, if Laplace transform of the function f of t equal to f of s, then Laplace transform of f of t by t equal to integration s to infinity f of s ds, where this f of s is nothing but L of f of t, provided that the integration of this part exists. So now the examples based on division by t. First example is Laplace transform of sin t by t. So by division by t, we know that Laplace transform of f of t by t equal to integration s to infinity L of f of t ds, where this f of s is nothing but L of f of t. So applying division by t, we can write L of sin t by t equal to integration s to infinity L of sin t ds. Laplace transform of sin t is equal to 1 by s square plus 1 ds. And integration of 1 by 1 plus x square dx formula is tan inverse x. Now using this formula, for integration of 1 by s square plus 1, we get tan inverse s, and the limits for s are s to infinity. Now when we substitute the upper limit as infinity, we get tan inverse infinity minus tan inverse s when we substitute lower limit as s. Since tan pi by 2 equal to infinity, so tan inverse infinity gives the value as pi by 2 minus tan inverse s, and pi by 2 minus tan inverse s is equal to cot inverse s. Here pi by 2 minus tan inverse s is nothing but cot inverse s. Since let's see how we are getting this result. So let us assume x equal to tan theta, then what will be theta? Theta becomes tan inverse x. Now we know cot 90 minus theta equal to tan theta. From this, what is pi by 2 minus theta? Cot inverse of tan theta. So pi by 2 minus, I am replacing theta with tan inverse x. So pi by 2 minus tan inverse x equal to cot inverse of tan theta is nothing but x. Therefore, pi by 2 minus tan inverse x is equal to cot inverse x. Now let's see one more example based on division by t. By division by t, we know that Laplace transform of f of t by t equal to integration s to infinity L of f of t ds. So L of, here f of t is nothing but e power at minus cos bt by t. So this is equals to integration s to infinity. Now write e power at minus cos bt in place of f of t, the formula. So now using linearity property of Laplace transform, this integrand can be written as L of e power at minus L of cos bt ds. So this is equals to integration s to infinity. L of e power at is 1 by s minus a and L of cos bt is s by s square plus b square ds. Now splitting the terms, we get integration s to infinity 1 by s minus a ds minus integration s to infinity s by s square plus b square ds. And as we know, integration of 1 by x dx is log x. So integration of 1 by s minus a ds is log s minus a minus, and to evaluate this integral I am multiplying and dividing this expression with 2. So now 1 by 2 into, this is of the form integration f dash x by f of x dx, and the formula is log f of x. So now here s square plus b square derivative is 2s in the numerator. So this can be written as log s square plus b square. Again this expression can be written as log s minus a minus log 1 by 2 into log s square plus b square can be written as log square root of s square plus b square. So log m minus log n is log m by n. So which gives log s minus a by square root of s square plus b square, and here take the limits from s to infinity for all the terms. Since I cannot substitute the limit as infinity in place of s directly, so I wanted to take s common in both numerator and denominator to substitute the limit as infinity. So we get log s into 1 minus a by s in the numerator, and whereas in the denominator if I take square root of s square common, I will get s into root over 1 plus b square by s square, and where the limits are from s to infinity. Now by cancelling, s we get the result as log 1 minus a by s divided by root over 1 plus b square by s square, where limits are from s to infinity. Now as s tends to infinity, here a by s tends to 0 and b square by s square also tends to 0. So now this expression gives the result as log 1 minus 0 by root over 1 plus 0. When I replace s with infinity as upper limit, and when lower limit is s, we get the same expression, that is log 1 minus a by s by root over 1 plus b square by s square. So which gives the result as log 1 minus log s minus a by s divided by square root of s square plus b square by root over s square gives s, and log 1 value is 0 minus, after cancellation of s, the remaining result gives the expression as log s minus a by root over s square plus b square. And this result can be written as this negative function of log s minus a by root over s square plus b square can be written as log root over s square plus b square by s minus a. Thank you.